Okay, so today I'm going to be showing you how to create a Hilbert curve on Blender using the Python editor, which is the Python script which is found in Blender. So without wasting much time, we'll start. So first of all, we have to make an import, which is the import for the Blender, which will be import bpy, and then after that we'll go into creating our very first function. So the function will be called detour xy. So what this function does is that it converts the one-dimensional distance along the curve into two-dimensional, so that's to make sure the Hilbert curve is two-dimensional, which is how it is by itself. So it will take two variables, n and d. So n will be the size of the grid along one side, while d will be the distance along the curve we are currently taking, so as to find the coordinates for the next step, or for the step which you're going to do. So after creating the function, we are going to create these variables t, which will be equals to d. Let me get some space. X, which will initiate to 0, y initiated to 0, and s, which will be initiated to 1. So what are those variables? So we copy d into t, so that we have our working variable, and then after that we'll take s, which represents the scale of the quadrant which we are at. So right now we'll be starting at scale of 1. So after that there's a while loop which will do. So while s is less than n, this is so as to zoom out the levels until we get to the scale of s, or we'll find our full grid of n. So over here we'll do rx is equals to 1 and t binary division by 2 by 2, and then ry will be equal to 1, and the same operation, t rx. So that's t bitwise operation rx. So what this will do is that it finds the specified point within our quadrant, so whether it's the fourth quadrant, the first, second, or third or fourth quadrant, so that it becomes either 0 or 1. So after that it's if ry is equals to 0, we do if rx is equals to 1, it's supposed to be equals, we take x and do s minus 1 minus x, and y is equals to s minus 1 minus y, and to that we do x, y is equals to y x. So what did this? So this will be our rotation logic. So this is because the defining feature of a Hilbert curve is that the subgrids are flipped and rotated so as start and end points connect perfectly with the neighboring grid. So this will be our rotation logic, and this bit flop and swap of x and y is based on which quadrant we are in, so that they don't end up crossing each other. So our next step will be x plus equals x multiplication of rx, y plus equals s multiplication of ry. We'll have t binary division by 4 and s So here we shift our x and y coordinates to the correct quadrant. So that's why we do the x multiplied by rx, or the not x but s multiplied by rx, or y multiplied by ry. And then after that we'd want to return the positions. So when this is all done, we do our return. So return x, y, and that's that function. So next we'll need our drawing function. So this function, we can call it I can say something sensible, so like create Hilbert curve, and this is what it will contain. So def create Hilbert curve, so order and size So here, for simplicity, we can set the order to be something like, I can say 4, so as to at least also save on my memory. And the size, we can set it to 5. So size is equals to 5. Okay, so inside it, the first thing we do is calculate the grid width in order to, so I can say to calculate the grid width so that it can be of the order, to fit the order, not so that it can be of the order. So the grid width, which remember was n, would be equals to 2, this is raised to the power of our order, and number of points will be equals to n multiplied by n. So like just like that, we've had the total points of our curve. So in this case it will be 2 raised to the power of 4, which is 16, and 16 squared, which will be 256, if I'm not wrong. Yeah, 256. So after that, we want a list that will be storing our points. This is supposed to be points, not point. And we'll do our loop. So for d in range num points, we want to do x, y, so as to get those coordinates and call our functions d2, x, y, and to give our n and our d. So we've created an empty list called points, and we'll loop from 0 to 255, hence getting all our 256 points, and calling our math function so as to get each one of those points. So after that, we'll need to normalize them. So we do px is equals to x xn minus 1 minus 0.5 and then multiply by size, and we give y the same treatment, so py is equals to y n minus 1 0.5 multiply by our size. So the raw x and y variables go from 0 to 15, and if we use those, the curve would be off center and would look quite huge. So we would want to normalize it so that it arrives at our origin of 0, 0 and appears, I can say, normal. So that's why we normalize it to the scale of 0.5, then multiply it by the size. So after that, we need to tell Blender to create a new raw curve data block in the memory. So we set it to be strictly two-dimensional and tell Blender not to fill the inside. So this is how we do it. We do too many spaces. So curve data is equals to Blender py dot data dot curves dot new name is equals to string, so Hilbert curve of order order, and then type is equals to curve. Make sure I closed everything. Yeah, and then curve data dot dimensions yeah, dimensions is correct, 2D, and then curve data dot fill mode is equals to none. Sorry about that. Is equals to none. So we've set everything we want to do, and after that we'd want to create a spline or a line. So we create one type, which is poly, and that means we create a straight line connecting points, not smoothly. So after that we do that. So for the line, spline is equals to curve data dot splines dot new, and then type is equals to poly, and spline points dot add num points minus 1, and after that we want to loop through our mathematically perfect points list, and that is where we can do our drawing as well. So sorry for misplaced. So for I p in enumerate points spline points I dot co is equals to p 0 p1 p2 1 that. So the 1.0 we are basically, the Blender poly requires a 4D vector, so the forward vector is W, so W is the radius, so it just assigns it to 1 so that it remains standard. And after that, keep going out of, so we do curve object is equals to bpi dot data dot objects dot new f string Hilbert curve of order, can write order, and curve data. The next bpi dot contacts dot collection dot objects dot link curve object. So far our curve will be existent, but only in memory, so we need to create an actual physical object for our curve. So to do that, we link or place the object into the active collection in our Blender, and the scene, and in our collection in our Blender scene, so you can actually see it. So this is where we do it. So bpi dot contacts dot viewer layer dot object dot active is equals to curve object, and then finally curve object dot select set, and set that to true. So after that, we've linked our curve so as it can appear on our screen. And after that, all we need to do is to just call this function. So over here we can do create Hilbert curve, and then order is equals to 4, and size is equal equals to 5, and just to make sure you can ensure this section of our screen is clear and can run it. Error. Oh, sorry, I think there's an error somewhere. I wrote curve. Let me look for where it is. Line 40. Yeah, so here it's supposed to say curves. Hope that's the only error. They seem to be created, but I'm not sure why they aren't visible. Maybe there's an error somewhere. Maybe you should zoom it out. Okay, let me try something. Have a cube. Maybe. Let me see what could be causing the code to fail. Hang on. I really think it should be running K, unless oh, I think I see the problem. I forgot to unnest this. It's it's not supposed. I forgot to unnest that, which explains why so many curves are appearing. Let's try it again. Let me just Control X and try creating a new script, pasting the code and seeing if it correctly this time. No, still nothing. Oh, I forgot to append the points. Is it the points? Yeah. Actually, I'm supposed to append the points because now it's pointing to an empty field. So px py 00. Python import 959. List object not callable. Oh, I forgot. Dot append. So px py 00. Did you mean append? Append. Takes one argument. Oh, I'm appending a list. I'm appending, is it a list or a tuple, into the list, so it's supposed to be in double brackets. Hopefully that should be, yeah. So that was the error, and now you can see we have our Hilbert curve. So that's it.